we've seen how we can use L'Hopital's rule to deal with indeterminate forms like 0 over 0, infinity over infinity, even 0 times infinity, or infinity minus infinity. But there's going to be some indeterminate forms where we're going to have exponents involved. There are 3 indeterminate forms that involve exponents, and kind of like the 0 times infinity, we have conflicting rules for that. We have one rule saying that the limit should approach 1. We're going to have other rules saying the limit should approach infinity, and so we have to figure out how to reconcile that. So this is just a definition that's in the book, or a theorem that's in the book, and the theorem says that if the limit as x approaches a of the natural log of f of x is equal to some constant limit, then the limit as x approaches a of the function itself, notice that here we have the natural log and here we don't, is equal to the limit as x approaches a of e to the natural log of f of x. And we've said here that natural log of f of x approaches L, so that's the same thing as e to the L. When we get problems that are going to use this theorem, the problem is going to be in this form. We're going to be asked to find the limit of some function, and this function is going to be one of the indeterminate forms that involve exponents. So what we're going to do is we're going to go off to the side and we're going to figure out what the limit is of the natural log of that function, and then we're going to use that to evaluate the limit using this formula. It allows us to work with these indeterminate forms: 1 to the infinity, 0 to the 0, and infinity to the 0. So 1 to the infinity is indeterminate because 1 to any power is 1, although understand that when we're doing limits, we're looking at numbers that approach 1 and are not necessarily equal to 1. So any number that is not equal to 1 to the infinite power is going to be infinity. So if we're looking at numbers that approach 1 to the infinity, we've got a conflict there, and we don't know which one's which. Here we have a rule. Anything to the 0 power is 1. 0 to any power is 0. So we don't know if it's going to be 0 or 1 or somewhere in between. Here we have a rule. Infinity to any power is going to be infinity, except anything to the 0 power is 1. So we've got a conflict there also. So these are the 3 indeterminate forms that this theorem is going to be very helpful with.